In artificial neural network, the basic unit is neuron, and there are many neurons are interconnected to each other, forming the network. That is why it is called the neural network. Now, today we will discuss in this lecture what are the different architecture that can be used to build the neural network. Now, all the architectures which are there in artificial neural networks can be divided into broad three categories called the single layer feed forward architecture, then the multi-layer feed forward architecture, and finally, the recurrent network architecture. Now, so these are the three different architectures, and then before going to learn these architectures, we will just quickly go through the mathematical details of a neuron at a single level. So, to do these things, let us first consider a problem. We can term this is an AND problem. AND is the one problem is basically very much popular in Boolean logic, and the AND problem is like this. So, this is the truth table of an AND problem. Now, this AND problem can be considered as a pattern matching problem or pattern recognition problem. Now, let us see how it can be considered as a pattern recognition problem. Now, we can consider if this is the neuron, this neuron has the pattern consisting of two bits like so this one and this one. So, x1 and x2. Now, these bits can be 0 0 or 0 1 or 1 0 or 1 1. That means, x1 can be 0 or 1, similarly x2 can be 0 or 1, and these are two bits can be considered a pattern. Now, what is the pattern recognition that this system will do, and it will give an output like. So, pattern recognition problem like, so if these are the patterns, if it is fed to this neuron, then it will give output 0. On the other hand, if this is the pattern, if it gives to this system, it will give an output 1. So, this way we can recognize the pattern whether it is 0 0 0 1 1 0 or it is 1 1. So, that neural network can be can correctly recognize this pattern either in the form of a 0 or 1. So, this is the one pattern recognition problem like, and it is basically nothing but a AND logic problem that is there in our Boolean algebra. Now, so this AND logic, and if this is the pattern, now let us see how the neuron can be designed to solve this problem. Now, so here basically if we consider this is the biological neuron. So, this pattern whenever gives to us, like see if we see this pattern we can say 0, and if we see this pattern we can say 1. So, it is a pattern recognition. Now, again so far this mimic of this neuron is concerned, that means in the perceptron it has two input x1 and x2 and the summation unit, and obviously W1 and W2 is there, and it goes there, and this is the transfer function phi which basically take the input I and then gives the output y. Now, we will just see exactly what are the different weights values, and then for this input, this means either 0 or 1, and here also 0 and 1, it can recognize the pattern. Now, so the idea about that means how the neural network is there to solve this problem, it is shown here. So, here we can see this is the patterns that needs to be recognized, and this is the our simple neuron, or we can say this neural network consists of only one neuron, and this is the only one neuron. It takes the x1 is the input, x2 is the input, and this 0.5 and 0.5 are the two weights in this case, and 0.9 is basically the theta, the threshold values, and then transfer function can be like this y wi xy, it is basically w1 x1 w2 x2 summation minus theta, theta is 0.9, then it will give the value either 1 or 0. So, this is just like a idea about how this pattern recognition problem like this can be computed using a single neuron as it is shown here. Now, in this single neuron, so few characteristics are important. These are the weights are there, we have to learn it. I gave you these weight values for an example, but you can ask that how these weights are calculated. So, we will see how these weights can be calculated. Similarly, 0.91 threshold value that we have discussed, then how this threshold value is known to us. So, we learn about how this threshold value is known to us. Now, this is the idea about how the neural it works for us. Now, this is a simple one pattern matching problem, that means 2 input AND problem that we have considered. The idea can be again extended 3 input AND problem and so on. Now, like this AND logic which is there in Boolean algebra, other logic like NAND, NOR, all these things also can be implemented using this neural network. And you know, Boolean logic is basically the basic things that is used there in VLSI circuit to develop our chips or computers processing unit, computing processing unit. Basically, it is the way it works, it is the same way it is also working here. That means, the way the VLSI chips are basically designed, and basically same way our neural network can be designed to solve the problem. Now, so the last example that we have considered, it is on a very simple one AND problem, but if it is a complex problem, that means if it consists of many inputs and then many outputs are to be considered, then that architecture will look like this. So, here we can see these are the many input x1, x2, x3 dot dot xn's are to be fed into the computing system, and it will produce O1, O2, O3 and On, the n number of outputs are there. So, it is basically m versus n one combination, that m input and n output is there. Now, so this kind of input, this kind of what is called the mapping from this input to this output can be managed by this kind of architecture. Now, this is the one architecture. If we see here, a number of neurons are stacked one after another. So, this is the one neuron, second neuron, third neuron and then nth neuron. So, if the number of output is n, then it basically require n number of neurons are to be stacked. Now, each neurons, if we see so all the inputs that are there is basically connected to all the neurons. So, x1 is connected to this neuron, this neuron, this neuron and this neuron. The likewise this neuron also connected to this neuron and this neuron. So, all inputs are connected to all neurons which are there in this series. And another important thing that you can see also, that there are all the inputs are connected to this neuron by means of some weights are there. So, x1, if this is the input to this one connected to this neuron, then it has weights W11, W12 and W13 and W1n. Similarly, this is the input, if it is there, then W21, W22, W23, W2n, and for the nth neuron, so it is Wn1, Wn2, Wn3 and Wnmn. So, this way all inputs are connected to all neurons, and this is basically the network of connectivity that we can check. Now, here the input that is given to there will be feed forward to the output like. So, that is why it is called the feed forward neural network, and it is also called single layer, because if this is the one layer of neurons. So, that is why it is called the single layer feed forward neural network. And in this network, so there are many weights. So, basically the weights that is there, it is like this. So, all weights are there. So, there may be, so weights is basically m cross n, a number of weights basically involved in this network, and this is called single layer and then feed forward because of the one layer, and then this input is connected to one layer only. And one important thing that I want to mention here again, so that in each perceptron, so this is the perceptron 1 and this is the perceptron 2 and so on. In each perceptron there are what is called the thresholding function. So, it may be the different thresholding function or transfer function, or maybe all perceptron having the same transfer function. So, if it contains the different transfer function, then the learning that is required is very difficult, but if it contains only one transfer function, learning will be simple and straightforward. Further, in each transfer function there is a thresholding value. So, that thresholding value also varies from one neuron or one perceptron to another perceptron. If each perceptron contains the different thresholding value, then again also learning will be there and that learning will take much time. So, here so far the neural network is concerned, and more precisely the single layer feed forward neural network is concerned, all the weights that is there to this layer are the parameters to be learned, and all the transfer functions that is there and with their thresholding values are to be learned. If we learn and also number of what is called the perceptrons in the layer also one factors to be learned. So, if we learn for a given problem all these parameters, then we can say that our neural network is trained perfectly, and once the neural network is trained, then if we give any input to this, it will produce the corresponding output. So, here only the matter of how a network can be trained or it can learn from the input to the output, and then once it is build the network we can use for solving our problem. So, this is the concept that we follow in artificial neural network. Now, we have started with first perceptron and we check that how AND problem can solve it. Perceptron is the very simple most one problem solving neural network. After that, just now we have learned about single layer feed forward neural network. Next, we learn about little bit different and complex the neural network architecture, which is called the multi-layer feed forward neural network. Now, again I just want to mention that I forgot to mention it there. So, in this particular neural network single layer feed forward network, the weight matrix W is there. It is basically the collection of all weights from any input to any neuron, any perceptron. So, these are the all weight values from the first input x1 to all the neurons 1, 2, 3 to the n neurons, and see this is the input from the mth weighted by these values are there. Now, all these things is basically can be stored by means of a m cross n matrix. So, it is called the weight matrix. Now, like this weight matrix, this is the transfer function that also needs to be learned, and this is the threshold value that needs to be learned, and this is for the kth perceptron, and it basically for the kth perceptron this is the kth transfer function with the threshold value, and given the input x1, x2 dot xm, and that we can consider as a matrix X. So, any ith input if it is given there. So, it is basically W dot x is basically the matrix product of the two weights, and then this one, then it will gives the ith what is called the summation unit to the ith perceptron. So, this way it can solve, and as you know the matrix operation is the one simple most and very fast operation. So, computing in a neural network is very fast, and then not a timing issues are there. Okay, so, this is the idea about single layer feed forward neural network, and so far modeling such a network is basically this is the mathematical form or the mathematical model that can be considered or that is used to solve problems. So, this is basically model of a single layer feed forward neural network, and the model can be expressed in a mathematically in terms of matrix and simple computation as it is here. So, modeling is there, and then so basically we have to build this model, means we have to find this is the W value and this is the value of this function. So, model means basically we have to learn this W matrix and Fk values, Fk functions for each neutron. Now, so this is the idea about single layer feed forward neural network, and we can extend the same concept to little bit complex neural network. Now, in case of single layer feed forward neural network, only one layer of perceptrons are there. On the other hand, in case of multi-layer feed forward neural network, instead of one there are many, out of which one layer which is connected to input data, it is called the input layer, and there is another layer which is connected to output is called the output layer, and in between input and output layer there are some layers of perceptrons is called the hidden layers. So, if L number of neurons in the input layer, that means there are L number of inputs. If n number of outputs are there, then in the output layer n number of perceptrons should be there, and therefore, so it is called the L and n combination. So, for the input and output is concerned. and in between this input and output layer there may be m number of hidden layers. So, m1, m2 dot dot m. So, these are the hidden layers, then number of neurons in these hidden layers again can be divided by that number, say in m1 layer m1 number of neuron, in m2 layer m2 number of neuron, and so on. So, a typical look of such a multi-layer neural network can be shown here. We say here in this figure I show one simple layer, a simple multi-layer feed forward neural network where 3 layers are there. So, this is the input layer, this is the output layer, and this is the only one layer in the hidden layer. Instead of only one layer, there may be like this many layers also can be considered. So, it will just increase the complexity of the network, that is all. Now, all the inputs are connected to this input layer and all the outputs are connected to the input layer. Here we can see p number of inputs and n number of outputs, and this network is called the multi-layer network because multiple layers of neurons are there, and it is also feed forward network because input passed to this, it produce the output, whatever the output produced by a particular perceptron gives the input to all other perceptrons into the next layer. Then this output also take this input from the different perceptron in the previous layers and produce the output gives to the this one. So, it is the same thing. So, it is basically in every layer we can say it is a single layer like. So, there is a what is called the stack of a number of single layers, all are highly connected to each others, and then it form the multi-layer feed forward neural networks. Like the modeling of single layer feed forward networks, the multi-layer feed forward networks also can be modeled in same way, but here more weight matrix, more transfer functions, and the different thresholding values are there. For example, so there will be one weight matrix is required to define all the weights here, another weight matrix is required to denote here, another weight matrix is required to denote here, because all the inputs are passed through the different perceptron via the different weighting values there. So, here we can say the weight matrix W1, here W2 and W3. So, in order to model this one, we have to know what is the weight matrix, what is the weight matrix at the different level. So, these are the modeling issues, and then for each perceptron in each layer the transfer function. So, it is F11, F12, F1, Fp1 like this one. Similarly, here also this kind of transfer functions are there, and in each transfer function thresholding values also to be considered. So, in order to model such a neural network, it basically modeling these are the weights and the different thresholding transfer function and then threshold values in each perceptron. Now, so all these things can be done again in a simple in a compact and mathematical form by means of different weight matrix and then different what is called the functions that it can consider. For example, this is the weight function that can be generalized to represent each perceptron in each layer. So, it is basically the output of the ith perceptron in the lth layer, and it is defined by the fi function, the transfer function, and this is the threshold function. So, this is from this is the unique values, unique functions from in each perceptron that is there. In addition to these are the different weights that needs to be considered there. So, modeling just like a single layer feed forward network, if it was modeled using only one weighting matrix, it will be modeled using 3 different weighting matrix. If it is modeled by a series of transfer function and threshold value, but it will be a large correction of transfer functions and thresholding values. So, modeling only will be little bit complex than the single layer feed forward neural in case of multi-layer feed forward neural network. So, this is the idea about multi-layer feed forward neural network. Next type of neural network that okay, it is called the recurrent neural network architecture. Now, the difference of this network architecture compared to the previous two architecture is that the feedback will be there, that means there will be a loop. So, it is called the feedback loop. So, there may be exist one feedback loop from the next layer to the previous layer. So, if feedback is there, then it is called the recurrent neural network. And okay. Now, so let us see how the such a network looks like. here is the one picture here. So, here basically if we see the output of this is feedback to this one, the output can be feedback to this one also, and here also output to the same leader. So, it is called the self loop and this is the previous loop. That means, it is more complex, because in addition to the conventional input there which will be connected, plus the output from any near to the previous perceptron is there. So, number of what is called the output to each number of inputs to each perceptron will be enormously high, and it thus leads to a very complex network architecture called the recurrent neural architecture. So, if there is a self feedback or recurrent things, then they are called the Hopfield neural network, Boltzmann meshing network, like this one. So, different networks are there, whether there will be a self loop or not, the loop from the next layer to just previous layer not, or the loop from one perceptron in a layer to any perceptron in any other layer or not. So, this way the different architectures can be thought, and then it is there. Now, again, so far the modeling is concerned, the same concept it can be applied here, and then same modeling will be there. Only the thing is that all the matrix that is there, they will have very larger size compared to the simple feed forward neural network. Now, so this is the recurrent neural network architecture, and there is the obviously the question is that which network architecture is suitable to which application. Now, we quickly go through this concept there, in which case the single layer network is required, in which case the multi-layer network is required, or in which case the recurrent neural network is there. Now, here let us consider this figure. In this figure we can see, so this is the input layer, and this is the one processing on output layer. So, neuron is there. So, it is just like a multi-layer feed forward network sort of thing, or we can say this input is directly come to here, this also we can consider, then this layer is not there. So, it is basically a single layer feed forward neural networks are there. We will consider 3 weights W0, W1, W2, and this theta is called the bias input, sometimes used there. Mainly there are 2 input x1 and x2, and this can be x0 also can be written like there. Anyway, so if this is a neural network, then we can say the transfer function will be look like this. So, basically the transfer function basically summation of the I input into their weights plus this is the threshold value. So, this is basically nothing but the threshold function, it is there. Now, so this basically f will return depending on the different values of theta and weights, it will return one output. Now, this basically if we see this is an expression of a straight line in a 2 dimensional space x1 and x2 if we consider the 2 dimensions there. So, it is a 2 dimensional data space x1 and x2, and for any input values having x1 and x2, it basically decide either this input is in these sites or in these sites. So, this basically a way it basically classify the data, it belongs to these sites or not these sites. So, it is also a classification or is a we can say prediction concept like, and this kind of prediction concept we can see how it can be solved using this single layer feed forward neural network. And in this case, if this kind of expression is possible, then this is basically a straight line. So, here the predictor or the classifier looks like a linear and straight line is there. Now, so this is a linear classification or linear prediction is there. Now, if this kind of predictions are there, then we can implement this kind of things using a single layer feed forward neural network. But there are some classifications are there where the data cannot be linearly separable. Now, exactly I can discuss about what is the linearly separable data is there. Now, so suppose these are the data and these are the another type of data. So, 2 patterns, one pattern is this one and another pattern is this one. Then we can think about a linear line to separate all the patterns into 2 parts. So, this is the one pattern type, another pattern type. So, then we can say that this data is linearly separable. But like here, if this is the patterns like this and these are 2 different patterns, then no linear line can be thought of. So, it is basically this is a very difficult to pattern by a linear line. So, then we can say that these are the data are linearly not separable. So, there are 2 type of data. So far the prediction or pattern recognition is concerned, data is very linear, that means it can be separate linearly and something is cannot be separate non-linearly. So, if the data is linearly separable, then we can use simple network, the single layer feed forward network. But if the data are not linearly recognizable or separable, then we should consider the network which is other than single layer feed forward network, that means multi-layer or recurrent near like this one. Now, so these are the basically rationale or genesis that in which situation we should follow which kind of neural network architecture. Now, here is an example that I want to give it. If the AND logic, that is the case we have discussed about. So, this AND logic has the pattern, these are the different input and this is another output. So, all the input can be patterned as a 0 and all the input in this side can be patterned as a 1. So, 2 patterns and there is a straight line like this one, which is the equation of this form that can be used to separate this one. So, this is the neural network and implementation of this neural network by means of this kind of lines, and then these data are linearly separable data, and then a single layer feed forward network can be used to train to develop this model. On the other hand, let us consider another problem, it is called the JOR problem. So, JOR problem has the pattern like this, whereby the output will be like this. Now, if it is like this, so different patterns it is there. So, here basically, so these are the one pattern and these are the another pattern. So, these are two patterns. Now, we can see that if this is the two patterns given to us, the data cannot be linearly separable. The data cannot be linearly separable means we need something else than the single layer feed forward. So, in this case we can follow the multi-layer feed forward neural network, and let us see how the multi-layer feed forward networks can be planned to design this kind of architecture. So, JOR problem is like this. So, it is linearly non-separable, and here is the architecture of the JOR problem. So, this is the one layer, the hidden layer, and this is the output layer, input layer, hidden layer and output layer. So, it is a 3 layers. In this hidden layer 2 inputs are there and 2 perceptrons, and in case of hidden layer again 2 perceptron, in case of output layer 1 perceptron. Now, here the different weights, here the different weights, here we can say the weights are this one, and here the different weights we can consider. So, there are 3 weight matrix are there, and here the 0 or 1 threshold value you can consider. The simple linear transform function just directly pass it, that means y equals to x, this kind of transfer function it is there. So, we have written blank, it is this is why. Now, here the different transfer function is to be followed, we will come to this, and then the threshold value that can be considered in each unit, it is shown here in the hidden layers, and also threshold value that can be considered here, it can be shown here. So, this basically the architectures which basically takes any input pattern and then produce an output according to the JOR logic, and this kind of things is possible only. So, JOR logic cannot be designed using single layer feed forward network, in fact no one can design it. So, it can be designed only using this kind of simple multi-layer feed forward neural network. Now, so these are the simple network that we have considered. Other than this network, single layer, multi-layer, there is another one network also known in the theory of artificial neural network, is called the dynamic neural network. Now, dynamic neural network come into the way that if at any instant, if we decide that this is the output and then we can calculate its error, that means output should be x and it is coming at x dash, then the error is x dash minus x. Now, if we utilize this error to configure our neural network automatically, then it is called the dynamic neural network. Now, so there is a static neural network versus dynamic neural network. In case of static neural network, no error computation takes place. On the other hand, in case of dynamic neural network, error needs to be calculated at every instance, and based on the error that we have obtained, the network parameters can be adjusted, then it leads to another neural network, it is called the dynamic neural network. So, you can understand that it is not a, obviously the feedback will be there, it is just recurring neural network type, but error needs to be considered as the feedback in each neuron. So, it is a concept and it is obviously too much complex. So far the network architecture is concerned and so far the computation is concerned, because in every instances we have to calculate the error and error can be propagated back to the previous layer neurons, and then that neurons then adjusted its weights or parameters values, so that the error can be minimized. So, this is the pictorial description. If the input is given to this, and this is the dynamic neural network architecture, output will give there, and there is a error calculation unit which basically calculate the error and give a feedback to this one, and using this feedback this neural network will automatically update or dynamically update, so that the error can be minimized or the zero error or the target output can be precisely obtained. So, basically this way automatic adjusting this neural architecture will takes place, and then neural net will give the best output, and in that case it is very fault tolerant or robust system can be developed. So, this is the concept of dynamic neural network. Now, so as a summary we can see that for linearly separable problems we can design the neural network architecture in the form of a single layer feed forward neural network. On the other hand, for non-linearly separable problems we can use either multi-layer feed forward neural network or the higher configuration like say recurrent neural network or dynamic neural network. And dynamic neural network in particular can be used for error calculation we solve, and then recurring neural network and then dynamic neural network we can use for the if we want to take into account the errors in the computation. So, these are the different architecture that we have learned, and next our task is basically how to model the different network architecture. So, modeling the different network architecture means how to learn the different parameters with which a neural network can be composed of. So, that will be discussed in the next lectures. Thank you.